Assalamu alaikum, dear students. I hope all of you will be quite fine. Uh, I have presented the solution of midterm exam for the subject of mechanics of machines that has recently been conducted. Uh, as we know that it is actually the requirement for the semester system that the midterm answer books should be shown to the students, as well as it is also the requirement that the solution of the midterm exam that should also be provided to the students. But I have thought that I would be further facilitating them, that I will be uploading the solution for the midterm exam, and as well as I will be making them understand, uh, so that they can easily understand that, and it will facilitate them while solving the interim exams. I have typed the solution for them, and here we can I can also show the brief glimpse of the uh, question paper that was actually conducted. Here, as we can observe, this is the brief glimpse or overview of the question paper that was actually conducted, and this is the solution. So I have copy pasted the statements of the question here, and as we can observe, the question one statement is here: mechanisms are shown figures 1a, 1b and 1c, so determine the following as required. So the requirements are listed here: the total number of links including the ground link. Similarly, the second requirement was revolute and prismatic pair. Third is the DUF, means degree of freedom of the mechanism, and fourth one is the full and half joints. Fifth is DF of the mechanism in figure 1a if both wheels roll with slipping. This fifth clause was actually only for this figure 1a, and these first four clauses were actually for all these three figures, and the fifth and sixth clause was only for figure 1a. As it mentioned here, that in the fifth clause it is mentioned that DUF of the mechanism shown in figure 1 if both wheels roll with slipping, and the sixth requirement is list the types of motion for each DUF as obtained in part 5 and which link exhibit that motion. That means that the resulting DUF will be explained that which part is actually exhibiting that DUF. So that was also the requirement, and so I have tabulated the solution here, that figure 1a, figure 1b and figure 1c here. I have tabulated the solution here. As we can observe, that I have generally I have not presented the detailed solution because that was a simple question. I have simply written here the two formulas. This is the Gruber formula: m is equal to 3 into L minus 1 minus 2j, and this is the Kurzbach equivalent, which is m is equal to 3 into L minus 1 minus 2j1 minus j minus j2, j subscript 2. So the first requirement, as we can observe here, that was that total number of links including the ground. So in the first question there were actually total 4 links which can be counted, like this is the ground, this is the right wheel which is connected this horizontal bar at point B, and this is the right wheel which is connected with this horizontal bar at point A. So there are total 4 links. This is ground 1, this is 2, this is 3, and this is 4. So there are 4 links. And in figure B similarly there are a total 6 links which can be counted like this, because this is the ground link including the ground. So this is first link, so link AB is the second link, link CB is the third link, and link DB is the fourth link, and the slider at C is the fifth link, and slider at D is the sixth link. And remember this rod on which slider are mounted, this is a part of the ground. So there are total 6 links. Similarly in figure 1C, as we can observe, this is the ground link here, and there are 2 pistons, so 2 and 3, and 2 connecting rods, so 4 and 5, and 1 is the crank AB. So there are total 6 links. As for the second class is revolute and prismatic pairs, in figure 1 we can observe there are 2 revolute pairs, which is actually the connection between this right wheel and this horizontal bar at point B. There is a revolute, or revolute pair means there is a pin, so this wheel and this horizontal bar can relatively rotate with respect to each other. And similarly in the left wheel at point A with the connection this horizontal bar, there is also the revolute joint. And there are two prismatic motions, because these wheels actually roll without slipping at this horizontal surface. So there are 2 prismatic motions. So in similarly in figure 1B we can observe here that revolute pairs here are total 5, so they can be counted, that there is a one revolute pair or joint between link AB and the ground at this pin. So this is one revolute. And here at point B, as we can observe, there are total 3 links connected, means link AB, link CB, and link DB. So there are 3 links connected. But as we can observe that here the terminology of order of joint can be applied, which is actually that states that the number of links connected at a joint minus 1. This is the order of the joint. So there are total 3 links connected, so the order of this joint at B is actually 2. So the order of joint is actually equal to the revolute pairs at this point, because link AB and link CB can independently move relative to each other, and link CB and link DB can independently move relative to each other. So here are 2 revolute joints. So up to here there are total 3 revolute joints, and the 4th revolute joint is actually between this slider at C and this link CB, and the 5th revolute is between the slider at D and the link DB. So there are 5 revolute and 2 prismatic. Prismatic means that the translatory motion or reciprocating motion. So that is actually between the slider at point C and this vertical rod on which is ground, which is fixed, which is mounted with the ground. And the other prismatic motion or sliding or reciprocating motion is between the slider at D and this vertical fixed grounded rod. So two prismatic pairs. In the figure 1c we can observe that there are two revolute joints between these two pistons and these two connecting rods. So there are two revolute joints between each piston and the connecting rod, and as at point B there are three links connected, means one is the crank AB and there are two connecting rods means DB and BE. So here the order of the joint concept is applied. So here are two revolute joints in a similar manner that we counted here at point B in figure 1b. So up to here there have become four revolute joints, and fifth one is the between this crank and the ground. So there are total five revolute pairs. And as far concerned the prismatic pairs, so between each piston and this ground there is the prismatic motion, one prismatic motion between this cylinder at D and this ground, and one prismatic motion between the cylinder at E and this ground. So there are two prismatic motions. And the third clause is actually the DUF of the mechanism, but before of the mechanism we can solve the fourth clause, which is actually full and half joints. So full joint are actually one DUF joints and half joints are actually two DUF joints independently. So in the first diagram figure 1a we can observe that there are total four full joints. As we can observe here, there is between this right wheel and this horizontal bar, this pin is also a full joint, and this left wheel and at point A between this horizontal bar there is a second full joint. And because between this horizontal surface which is ground and between each wheel it is mentioned here that the connection between these two wheels and the ground, there is no slipping case. No slipping means they actually roll without slipping, or there is a one-to-one connection between the periphery or circumference of these two wheels, just like gears teeth mesh with each other. For example, we can assume that this horizontal surface is like a rack and these two wheels are like pinions. So as the rack and pinion connection, there is no slipping, so or alternatively we can also state them like the friction discs. In the friction disc there is no slipping, means there is a one-to-one contact when they purely roll. So when pure rolling is there, we actually count them as full joint or one DF joint. We do not consider them as the roll slide joint. So as no slipping is mentioned, that means pure rolling. No slipping, alternatively we can state it pure rolling. So in pure rolling apparently the half joint is counted as the full joint. So here are four full joints and there is no half joint. So in figure 1b we can observe here that as we have already counted, there are five prismatic pairs and five revolute pairs and two prismatic pairs. So their sum is actually all full joints. So there are total 7 full joints. So because the prismatic pairs and the revolute pairs are each full joints, so 5 revolute pairs and 2 prismatic pairs, so that means their sum is actually total full joints. But as there is no roll slide or there is no point or line contact, so there is no half joint, so 0 half joints. Similarly, in the figure 1c, as we can observe here, there were total 5 revolute and 2 prismatics, and their sum is actually the total full joints. So R1 full joints, and there is no half joint because there is no roll slide, or there is no slot or pin connection, and there is no point or line contact. Now we can solve the third class, which actually state the degree of freedom of the mechanism, because as we can observe, this general formula is written here, where L is the total number of links including the ground. So the first row in this table actually shows the total number of links including the ground. So L minus 1 in the first case will be equal to 4 minus 1, that will be 3. So 3 multiplied by 3 will be 9. So total 9 DUF will be available for this mechanism. Total available DUF will be 9. So from this will be subtracted the DUF that will be removed with the help of these full joints in the fourth row. So there are 4 full joints, so that means each joint, actually full joint removes 2 DUF. So there are 4 full joints, so 2 multiplied by 4 will be 8. So 9 minus 8 will be equal to 1, so this will be 1 DUF. In a similar manner, if we move to figure 1b, we can observe here the total available DUF will be 6 minus 1, because capital L is equal to 6. So 6 minus 1 will be 5. 5 multiplied by 3 will be 15. So available DUF for the mechanism in figure 1b will be 15, and from this available DUF, the DUF will be removed by full joints, that will be subtracted. So there are 7 full joints, because 5 revolute and 2 prismatic, their sum is equal to 7. So they will total be removing 7 DUF, because there is no half joint. So there 15 DUF is available and 14 DUF is removed, so the mechanism DUF of the mechanism is 1. In a similar manner, in figure 1c, we can also observe that here the total available DUF will also be 15, and there are total 7 full joints. So 7 multiplied by 2 will be 14. So 15 minus 14 will be 1. So in this way, 4 clauses have been solved. As far as concerned in the 5th clause, it is mentioned that DU of the mechanism figure 1, if both wheels roll with slipping, means there is a we will be assuming now that between the connection between each wheel and this ground is actually the roll slide, or like a pin in a slot connection, or 2 freedom joint. So if there is a 2 freedom joint, so we can better use for example formula viscous batch modification. So we can observe that the number of links are same, there are 4 links, but here there are 2 half joints, because now the slipping is available. So that means rolling is also there and slipping is also there. So that means these have become into 2 freedom joints. So 2 freedom joints are denoted by J subscript 2 in batch modification. So J2 value is 2, J2 value is 2, and J1 value is also 2, as we can observe here the 2 revolutes at point A and B. So total available DOF is 9. So 2 multiplied by 2, that will be minus 4, and minus 2. So there will be 9 minus 4 minus 2 means 9 minus 6, that will be equal to 3. So total available DOF for the mechanism, if we assume here the slipping case or roll slide joint or half joints, so the available DOF will be 3, and those 3 are actually that they can be explained here like this, that for example we fixed this horizontal bar AB. For a moment we just fix this horizontal bar, just we hold in our hand and keep it static, means no motion of this horizontal bar, and we can independently roll or rotate this left wheel about this point A. So this is one DUF. So in a similar manner, if we for example momentarily keep static or stationary this left wheel and this horizontal bar, we can independently revolve or rotate this right wheel about this point B, because here is a pin. So that will be the second DUF. And the third DUF is that we can momentarily keep stationary this right wheel, this horizontal bar, and this left wheel. So all these three links will be kept stationary, and we can simultaneously move them as a one unit. We can drag them on this horizontal surface in the right or left orientation, means we can momentarily fix, or just like we can weld them with each other. These three links means this uh, left wheel and this horizontal bar AB and this right wheel, and we can drag them as a unit on this horizontal surface in the right direction or in the left direction. So that will be the third DUF. So that has actually I have briefly stated here that two rotations independent for each wheel and one translation for both wheels. For both wheels, or we can also add that and the rod. So in this way there will be three independent motions available, so they will be treated at the DUF. So in this way question 1 has been solved. So now move to the statement of question number 2, that says that an advanced multi-DUF, assume 7DF robotic mechanism is to be designed using number synthesis to determine the number of links up to hexagonal order. So to hexagonal order means up to hexagonal orders, means binary links can also be the 7DF robot can include binaries, ternaries, quaternaries, and pentagonal links and hexagonals, means there can be no link greater than the hexagonal order. So and all full joints, only revolute joints means full joints, are all full joints, 1DUF joints. So the first clause is determine the minimum total number and order of links required, and second was describe briefly the synthesis process for a total 12 number of links, and third was the use tabular approach to find the number and order of links if there are total 14 links. So the solution was quite simple. So move to the solution. Question 2 first part, which is actually determine the minimum total number and order of links required. So we can write equation 2.6, which is equal to L minus 3 minus M is equal to T plus 2Q plus 3P plus 4H, and 2.4a, which actually combines all the types of order of links and their count. So as we can observe that the DUF M, that is requirement, that is actually 7 DUF. So equation 2.6 that actually states that then when we will be putting M is equal to 7, so L minus 3 minus 7 will be equal to L minus 10. So this equation 2.6 will become T plus 2Q plus 3P plus 4H. So in this equation, as we can observe that from equation 1, L cannot be less than 10, because if for example L is equal to 9, so that will be -1. So that means the negative links, because on the right hand side links can never be negative. So we can observe that the minimum L, this equation number 1 states that the minimum value of number of links must be 10. So 10 minus 10 will be 0. So that means minimum value of number of links is 10. So if we put in this equation number 1, we obtain that 10 minus 10 is equal to 0. So that means all T, Q, P and H are 0. So that means minimum 10 and all binary links will be there. So in this way solution has been. So the solution of this first part was quite simple and quite logical. And now move to the solution of part 2 of the question number 2, and that actually required that for link total number of links 12 and df is equal to 7, but it was actually requirement that student will be mentioning or describing the brief procedure. So I have written here the brief procedure. So as we can observe, to equation 2.6 gives that L minus 3 minus m, so L is equal to 12. So minus 3 minus m is equal to 7. So my minus 3 minus 7, which is equal to minus 10. So 12 minus 10 is equal to t plus 2q plus 3p plus 4h, which is equal to 2. So as we can observe, on the right hand side there is 2. So that means even if for p and h, for any of the p and h, if there is for example we can take value other than 0. For example, we can, the lowest value other than 0 can be 1, means 1 pentagonal or 1 hexagonal. So in any case, if we take for example h value is equal to 1, so that means that will also give negative number of links. And also if we put the value of pentagonal link, means p is equal to 1, that will also give negative, because on the right hand side there is 2. So that means p and h will be 0 to avoid the negative number of links. I have actually explained it for many times in the previous videos that have been uploaded, but I am again and again explaining so that student actually well know it and memorize it. So this equation will be resulting that t plus 2q will be equal to 2. So here we can observe that q can actually adopt only two values, 0 or 1, and cannot obtain or adopt the value greater than 1. So as we can observe that if q is equal to 0, then simply t will be equal to 2, means 2 ternary links, and this will be actually giving this the other equation, which is actually 2.4a, that will actually be giving, as we can observe here, that will be given 12 minus 2, the 10 binary links. So in this way the first combination will be equal to 10 binary links, 2 ternary links, and all q, p and h will be 0. And if we take the other binary value for the quaternary link, which is actually 1, so if quaternary link is 1, and for this equation we can observe that 2 minus 2 will be, t will be equal to 0. So the other equation, which is equation 2.4a, which that will be giving 12 minus 1, that will be giving 11. So the next combination will be binary 11 links and 1 quaternary links, and t, p, h, means ternary, pentagon, hexagon link will be 0. So I have tabulated the values. L is actually the total number of links, and binary, ternary, quaternary, pentagonal and hexagonal here I have listed here. In the first case there are 10 binary links, 2 ternary links, and all quaternary pentagon hexagon link 0. And in the second set there can be these are possible sets, 11 binary links and 1 quaternary links in this way. So again, it was not the requirement to check the validity, so I will not be mentioning here the validity of the links in this table. So now move to the third part of the question number 2, which is the mentioned here was the tabular approach. So in the tabular approach, it was required that the total number of links were 14 and DUF was same, m is equal to 7. So I have listed here the equations, two equations. We can mention here their number. So this equation was actually equation 2.6, and this equation, as previously listed, this equation is actually this equation is actually 2.4a. So as we can observe here, we can observe that from equation 2.6, so L minus 10 will be equal to T plus 2Q plus 3P plus 4H. So 14, L is equal to 14, 14 minus 10 will be equal to 4. So as we can observe in this equation that the hexagonal link can adopt only 0 and 1 value and cannot adopt greater than 0 or 1 value, or greater than 1 value, because if for example h is equal to 2, so that means on the right hand side there is 4, so the number of links will become negative. So as previously explained for many times, so if we consider first binary value, for example h is equal to 0, so here the tree has been shown for h is equal to 0 case. If h is equal to 0, so the equation 2.6 and 2.4a will be respectively change or turn into t plus 2q plus 3p is equal to 4. So the lower equation 2.4a will be b plus t plus q plus p is equal to 14. So in a similar manner, again we will be starting the same procedure, that we will be starting from the highest order link, which is actually pentagonal link, and its lowest count. And as we can observe in this equation, p can adopt only 0 and 1 value and cannot be greater than 1, because if p is equal to 2, so that will be giving here 3 multiplied by 2, 6. So on the right hand side there is 4, so 4 minus 6 will become negative, so that is impossible. So in a similar manner, if p is equal to 0, so that branch goes here. The resulting these equations will be t plus 2q is equal to 4 upper equation, and the lower equation will be b plus t plus q is equal to 14. And here we can observe that q can adopt 3 values, means q can be 0 in this equation, q can be 1, and q can be 2, but again in a similar manner cannot be greater than 2, because on the right hand side there is 4. So the maximum value can be 4 on the left hand side for any number of link. So because here the highest order link is quaternary link, so if q is equal to 0, as we can observe, t will be equal to 4. So here there will be 4 ternaries, and the lower equation will be giving that quaternary is 0 and ternary are 4. So 14 minus 4 will be giving 10. So 10 binaries, 4 ternaries, and all others means q0, p0 and hexagonal is itself 0. So this will be the first set, means 4 ternaries, 10 binaries, 10 binaries and 4 ternaries. This will be the first set. And for the third set, q will be equal to 1 in this equation. So if q is equal to 1, so 4 minus 2 will be equal to t ternary links will be 2, and the lower equation will give that 1 quaternary and 2 ternary. So that means b plus 3 and 14 minus 3 will be equal to 11. So 11 binaries, 2 ternaries and 1 quaternary. So 11 plus 2 13 and plus 1 14. So hence second set has been obtained. And if we take the third value of q is equal to 2, so that will be giving t plus 4 is equal to 4. 4 minus 4 will be t will be equal to 0, and the lower equation will be giving that b plus 2 is equal to 14. So 14 minus 2 will be 12. So binary links will be 12 in this manner. So in this way, 3 sets have been obtained while p is equal to 0 and all hexagonal link is also 0. So the other value of the p was 1. So the fourth set will be obtained from this p is equal to 1. So if p is equal to 1 in this equation, upper equation, we can observe that t plus 2q will 2q plus 3 will be equal to 4. So 4 minus 3 on the right hand side will be giving 1. So t plus 2q will be equal to 1, and the lower equation will be giving b plus t plus q plus p is equal to 1. So 14 minus 1 will be equal to 13 here. So again the same procedure we can observe here that t plus 2q is equal to 1. So that means that q can only be 0, because even if q is equal to 1, that means t plus 2 will be equal to 1. So when this will 2 will be arrive at the right hand side, so 1 minus 2, so means ternary link will become negative, which is impossible. So that means q can only adopt only one value for this equation. So q is equal to 0, and when q is equal to 0, when q is equal to 0, so that means ternary link is actually 1. So 13 minus 1 will be binary will be equal to 12. So there will be one ternary and 12 binary links. So 12 plus 1 is 13, and plus 1 this pentagonal link. So the fourth set will be 12 binaries, one ternary and one pentagonal link. In this way fourth set have been obtained, and now we will be considering the other binary value of hexagonal link, which is equal to 1. So if h is equal to 1 in this equation, so this equation will be changed into t plus 2q plus 3p plus 4h. H is equal to 1. So as we can observe, on the right hand side is 4, so 4 minus 4 will be equal to 0. So t plus 2q plus 3p will be equal to 0, and the lower equation will be changing b plus t plus q plus p plus h. H is equal to 1, so 14 minus 1 will be equal to 13 in this manner. So again we will be repeating the same procedure, because on the right hand side there is 0. So as we can observe that on the right hand side there is 0, so that means p can necessarily be equal to 0, because we will be starting from the highest order link and its lowest count. So p cannot be equal to 1, because if p is equal to 1, so that means on the right hand side there will be minus 3. So t plus 2q will be equal to minus 3, that means, which is impossible. So P must necessarily be 0 in this equation. So that means if P is equal to 0, the upper equation will be changing into T plus 2Q is equal to 0, and the lower equation will be B plus T and plus P plus Q is equal to 13 because P is equal to 0. And now again the same procedure in this equation, as we can observe on the right hand side there is 0, so that means the highest order link Q can only be 0, cannot even be 1. So if Q is equal to 0 as it is mentioned here, so T will also be equal to 0, and the lower equation will be simply giving B is equal to 13, and this last set will be equal to 13 binary links and one hexagonal link as in the start it has been assumed. So in this way all five link sets have been obtained, and those link sets are mentioned here as we can observe here in the tabular form here. Remember that this is the table, actually that is the tabular approach of solution, and this is the final table. So as we can observe, here are 5 link sets. So first set is 10 binaries and 4 ternaries, and second is 11 binaries and 2 ternary and 1 quaternary, and the third set is 12 binaries and 2 quaternaries, and the fourth set is 12 binaries, 1 ternary and 1 pentagonal link, and the fifth set is 13 binaries and 1 hexagonal. So these last 3 columns have been added optional here in the solution. They were actually not the requirement in the exam. So in the exam it was only the requirement that student will be preparing only these 5 columns. These 5 columns means binary, ternary, quaternary, pentagonal and hexagonal links, and this total number of links column. So in this way the solution of question number 2 has been completed. Now move to the solution of question number 3, and a statement is also mentioned here. And the statement is mentioned here, you can read it here. And if we move toward its solution, we can observe here the solution has been mentioned for the question number 3. Sorry, here as in the question number 3 in the first class, I will be reading the statement that an offset slider crank or crank dash slider is the general mechanism used in IC engines, rotary engines, reciprocating pumps, compressors, well systems, shaping and slotting machines, or even in a bicycle movement on road straw, depending upon how input is applied or output is obtained. Here we can observe, just for the explanation or for the matter of interest, that in a bicycle movement we can observe we actually input to the pedals. Just like the crank dash slider mechanism, and the bicycle movement on the road is actually equivalent to the slider movement. So the movement of a bicycle is actually crank dash slider mechanism, because in the crank dash slider terminology input is given to the crank. So if we input or if we pedal with the help of our feet, so that means we are inputting the crank. So crank is actually the input, and in a similar manner in the IC engine the slider crank mechanism is used, because the input is given to the slider or the piston due to the exhaust combusting gases, which actually reciprocate or move back and forth the piston, and which in result actually moves the crank and the crank pin and the crankshaft, and that actually engages with the transmission system to the wheels, which finally result the rotation of the wheels on the road, and the vehicle moves. And the rotary engine and the reciprocating pumps. In the reciprocating pumps, compressor, and in valve system, usually the crank dash slider mechanism is used in the shaping and slotting machine, and as well, because in a shaper the tool movement is actually the output, because the input is given to the crank with the help of ram system, which is actually in a shaping or slotting machines, etc., and the output is obtained at the cutting tool movement. So this is just for the explanation of the statement, which was actually necessary for the solution point of view. That was actually only added for the interest of the students. So the common data that was actually for the both mechanism, that was actually a is the scalar length of the crank, which is the usually denoted by the link 2, so that was 200 millimeter, and B is actually the length of the connecting rod, which is usually denoted as the link number 3rd in the textbook of design of machinery, and C is actually the offset. So that was actually told to the student while in the exam, that C is actually the offset, that is 220 millimeter. So the first clause, the first requirement in question number 3rd was that draw a neat labeled position diagram for the crank dash slider, means crank is the input and slider will be the output. And remember that I have told many times that when the crank dash slider like terminology is written, that means crank is the input, so input will be unique, or its location will be only one, and the output or the slider will have two locations, so there will be two possible locations of the slider for the input position or location of the crank. So theta for the crank or input is mentioned here. Theta 2 means input is the crank, and crank link is usually denoted by the subscript 2 as the link 2. So theta 2 is equal to 40 degree. So using suitable scale, say for example 50 millimeter is equal to 1 centimeter. So scale was also given in the exam to help and facilitate the students, and the requirement was that measure and enlist the connecting rod angles and slider positions for both circuits and verify the results using analytical formulas as given. So I have given here the solution on the next page. So I have drawn this diagram on Microsoft Word, and the method I have explained it many times already. Many videos have been uploaded here, and as we can observe here, here some terminologies are missing, like this for example, this is angle theta 3 subscript 1, but we must remember that these subscripts as we can relate with the diagram here at here I can show the relevant. So here as we can observe that just like this is actually theta 3 1, but remember that this theta 3 1 and theta 3 2 can alternatively be used. So the author has mentioned here theta 3 open and theta 3 cross. So actually these formulas which have been derived here, the formulas which have been derived here, because this is theta 3 1 and this is theta 3 2. Usually it is the practice that theta 3 1 is actually the right hand side circuit and theta 3 2 is actually the left hand circuit. But remember, I have verified that this theta 3 1 and theta 3 2 can be alternatively used. So that is not actually necessary that theta 3 1 is necessarily located on the right. It is not necessary. And theta 3 means any of the theta 3 1 or theta 3 can be located at any location. So we will be practically inputting the values and verifying the result, and which formula will be giving the correct results or values that will be treated as theta 3 1 and theta 3 2, because conventionally the author has mentioned theta 3 1 for the right hand circuit and theta 3 2 for the left hand circuit, but actually practically this is not the case. And in figure 16b, this is the output or the slider location. So that will actually be deciding the net output value, which is the slider location. So in a similar manner, this is the diagram or solution. So this is equal to theta 3 1 for example, and this is equal to theta 3 2 or for the cross circuit, and this can be for the open circuit, and all labels are shown according to the diagram. And the procedure that here are shown two coordinate systems, mean capital X and capital Y, and its origin is at O subscript 2, which is actually the crank grounded pivot, and this is inclined at 45 degree, and its scalar length is 200 millimeter, and connecting rod. And the procedure is simple, that I can orally state here, that for the case of crank dash slider mechanism, we will first of all be placing the crank at correct angle of 45 degree with the help of protractor, and its length will be measured according to the scale that will be mentioned according to the scale. So O to A will be mentioned, that will be the input. After that we will be offsetting this slider axis line, and offset is given C is equal to 220 millimeter. So according to scale, if we can observe the conversion here, that C is equal to 4.4 centimeter according to the scale mentioned, and A is equal to 4 centimeter and B is equal to 10 centimeter. So in this manner the slider axis, and here according to the book I have mentioned at point B the local coordinate system, which is actually small x here, actually here must be small xy system, and whose origin is at the slider location. So as we can observe, the directions of the vectors are according to the book. So this is theta 3 1, and in a similar manner anti-clockwise angle theta 3 2 is actually 351. So this is the slider center line, and we can also observe that slider offset C is actually positive. So if the slider offset is positive, that means the slider will be located in the first or in the second quadrant, because in these both cases the offset will be positive. But in the book, in the example 4-2, actually the offset was negative, and due to that reason due to that reason that was below O2. So that was actually negative because the origin of the global coordinate system capital X and capital Y is always conventionally taken at the grounded pivot of the crank, and the local coordinate system small xy, which actually the author has not mentioned here, uh, that is taken at the slider location. So in this way, this is the actually the graphical solution, and here the values of d1 and d2 according to scale have also been listed, angles has also been listed. So the graphical solution is quite clear from this diagram. If you have still any confusion, you can personally meet and ask. You will always be welcome. So graphical solution has been completed, and after that I have applied the analytical formula. So analytical results, so first is the connecting rod angles, means theta 3 1. So as we can observe here that that is equal to the formula is given according to the book, so which is equal to sine inverse, and a is equal to 200 and theta 2 is 45 degree, and c is actually positive, which is equal to minus 220 millimeter. So that will be divided by 500. So I have just written here, these are not actually written in a exact mathematical style. I have just typed here just to make you understand. So the brackets may have some variation. So as we can observe here, the angle is mentioned here, minus 9.0419. So this is the analytical value for the connecting rod angle, and as we can observe here that this angle is actually resulted from theta 3 1 formula, but this negative value that actually denotes that angle is measured clockwise from the positive x-axis. From the positive x-axis the angle is measured clockwise, and that is equal to 9.0419 degrees. But as we can observe here that if we measure from this positive x-axis, here this coordinate system, for example this x-axis small xy local coordinate system, so as we can observe the 9 degree will be here. So that means theta 3 1 is actually for this left circuit. So as I have already explained here that we should not strictly stick to the notations that the author has derived these formulas. So theta 3 1 according to the book, the result is the answer is actually for theta 3 2. So this minus 9.0419 is actually theta 3 2, or the angle for the left hand circuit. This is the angle for the left hand circuit, because as I can show here that if we move to the left hand connecting rod, so this angle is actually minus 9 point, means this is the positive x-axis. So in the clockwise orientation up to this, that will be equal to 9.0419, which if we subtract from 360 degree, this actually gives 351 approximately. This is the graphical result, but the practical result in the analytical formula. So in this way, but if we use theta 3 2, we can observe that theta 3 2 actually gives the value of analytically 189.9, or we can simply here type that this will come out to be equal to 9.0419. so that will be equal to 189.0419 degrees. So that will be counter uh, clockwise. So as we can observe here that this angle is 189. So this is the graphical result. So that is mentioned here. So as we can observe, theta 2 is actually theta 32 is actually giving the angle for the right hand circuit or slider location. So remember that theta 31 and theta 32 can be alternatively used. So we should not strictly stick into the notations that has been adopted in the book for the derivation of these formulas. So in this manner, in this way, slider location have also been counted, and the formula for the slider location is mentioned here. So the left hand slider location, as we can observe, so we will be inputting the corresponding formulas. So the left hand slider location, sorry, this is actually the mistyped here, must be right, right side slider location. So as we can observe that for the right hand side slider location, the angle theta 3, the angle theta 3 is actually 189.0419. so input here the exact analytical value 0419. So that actually the result somewhat 635.26 millimeter. So as in the graphical results here it is mentioned that the according to scale the value was 13 centimeter. So scale was 50, so 13 multiplied by 50, that is came out 650. So remember our value is very nearly equal to the given, because here even if for example we change it to 13, because that is actually measured just by observation. So just one or two mark can also change a lot of difference in the final result. So for example if we take for example 12.8 for example instead of 13, so I can show it here in the calculator. That for example instead of measuring 13 by observation, I can mention here for example 12.8 and multiplied by 50, so this will be equal to 640. So as we can observe here that one or two graduation or mark values can make a lot of difference, but that is actually the procedure is 100% correct. So our value is also very nearly equal to the analytical result. So in this way D1 is approximately equal to 650 millimeter or between the this analytical result. So any value is actually acceptable. So graphical results, so 15 to 18% errors or discrepancies are allowed if the method is all correct. So for the left hand side slider location, we can observe we will be inputting the corresponding angle which is equal to 351 or minus 9.0419. so here we can exactly input the angle because I have actually input the graphical results, but we can exactly input the angular value analytical results. So 360 minus 9.0419, so which is equal to 350.9581. so 350.918, so that exact 9581 9581, so that can be exactly input, and that will be given somewhat result according to this, that is minus 352.42, and our graphical results show that is equal to 350. So the same logic applies here, that 1 or 2 mark can make this difference of 2 millimeters or 3 millimeter, so that is acceptable and 100% correct. So here I have listed here the final result, that theta 31 the connecting rod angles. Here graphically it is equal to 189 counterclockwise for the right hand circuit, and analytically it is equal to 189.0419 degree counterclockwise, and in a similar manner theta 32. And as we can observe here in the listing, that the formula for theta 32 actually gave the result for theta 31 in the table which I have created. So here again it has been verified that these formulas, notations or substitute can be alternatively used. So theta 32 is 9 degree clockwise, so that is due to this reason there is a negative sign here preceding this result, because this conventionally the angles in the clockwise orientation are treated as to be negative. So here theta 32 analytic result is mentioned here as well, and in a similar manner this is the D1 graphical result, and this is the analytical results, and this is the D2 negative 350 and negative 352, and the negative sign actually shows that the slider location in the second quadrant, because in the second quadrant x-axis is actually negative, so that is why the negative sign is here. So these analytical results are giving the negative results. So in this way this is the answer for the question number third, first part. So now move to the solution of question number third, part 2, and the statement for the part 2 is draw neat and label position diagram for the slider dash करें if D. So here the input actually D is actually the slider location, and it is positive, means the slider is located in the first or the second quadrant, but assume that it is located in the first quadrant. So using suitable scale is also given 50 mm 1 cm, and measure and list the crank connecting rod angles. So here the output will be the crank angles and the connecting rod angles for both the circuits, and verify the results using analytical formula. So scale is mentioned here as well. So here is shown the diagram which has been drawn on the Microsoft Word, like the procedure already shown in many videos. So here it is a labeled diagram as we can show here, that here these are the respective angles. So this is theta 31 186, and theta 32 for example this is 215 degrees. These are graphical results. So in the graphical result there are decimal values of the degrees cannot be measured quite easily, they can only be approximated. So I have measured these angles up to full marks, full graduations or full markings on the protector scale. So the angles for the crank are 60 degree, means theta 21, and theta 2 subscript 2 is theta 341. So this is the crank pivot, and this is the side axis center line. In a similar manner, the offset is positive orientation, which is equal to 220 millimeter in the upward direction. So slider is in the first quadrant, and slider is actually the input, and the procedure, for brief procedure for drawing this mechanism is that we will first of all be defining the global coordinate system whose ground is at point O2 at the crank ground pivot, and after that we will mentioning the offset C in the positive orientation, because in the statement C value is positive, so the slider is assumed to be in the first quadrant, for example. So once the offset, and this is the local coordinate system, small xy slider center line. So after that we will be doing that, we will be drawing the crank circle, and crank radius is actually 200 millimeter, which is mentioned in the statement. So we will be drawing the crank circle, and after that we will be taking the center point of the compass at the point B at the slider location, and we will be opening the compass radius equal to the length of the connecting rod, and the center or pin or needle of the center of the compass will be placed at point B, and we will be describing a circle equal to the radius of the connecting rod, and that circle will be intersecting this crank circle at two locations, at A and A dash. And here due to the movement of the this diagram, just location has been a slight changed, so I can simply we can move it here and like this. So here again, so here it is correct, because actually due to adding the text, this diagram was moved, so that was a bit changed, so I have placed it in the correct orientation just by moving it here. So in this way I have stated that we will be taking the center at the point B at the slider location, and we will be opening the compass equal to the radius of the connecting rod, or B, which is the scalar length of the connecting rod, and that circle will be intersecting at two locations of this crank circle, and these angles will be measured with the help of protractor. The procedure have been mentioned already many times, and the videos are available at the YouTube. You can take help with them, or it is crystal clear. So in this way the graphical results are listed here, and after that we can verify the analytical results. So analytical formulas are given here, K1 and K2, and these calculations you can do them yourself. In this way all A, B, C have been calculated, and this is the formula for the crank angle output, because the theta2 is the crank locations. There are two values will be for the crank angles, theta2 subscript 1 and theta2 subscript 2. So because in the slider dash crank, slider is the input and crank is the output, so crank has two locations, so two possible values as it is mentioned here, shown here. So in this way we will be obtaining two values of the crank, and that have been mentioned here. Theta 21 comes out to be 59.228 degrees, and that is counterclockwise. And theta 22 from this formula, when we input the values here, the result is minus 18.9553 degree. So negative sign actually, that means counterclockwise measurement, or alternatively its counterclockwise counterpart, that will be obtained from subtracting this value from 360, so that will be resulting 341.0447 degrees counterclockwise. So these are two values. But now again, as in the example I will be quoting here, giving reference here, that as in the fourth step of example 4-3, and the fourth step for which I have already uploaded the videos, that he has mentioned here that find the two values of theta 3 from either of equation 4.16a or 4.17. Calculate theta 3 with both equations for one value of theta 2. So these equations, which have are already shown here, I have listed them here, that theta 3 will be determined, theta 3 and d will be determined for every value of theta 2 1 and theta 2 2, as per the step 4 of example 4-3. So as we can observe here, that I have tabulated the result here, that for theta 2 1, which is equal to 59.228 degrees counterclockwise, so theta 3 1, if we apply theta 3 1 formula for the same theta 2 1, and if we apply theta 3 2 formula, so we will be obtaining these results. So theta 3 will be value, this will be minus 5.527, which is incorrect, and the d value will be equal to minus 359 millimeter, which is also incorrect. So if we apply the formula for theta subscript 3 2, so the value of theta 3 will be equal to 185.527, which is actually correct according to the diagrams as can be shown here. That here is a graphical value is 186. So our value analytical result is shown here 185.527, so which is 100% correct. So when we input this value of the slider formula, so the result will be equal to 600 millimeter as given, so this value will be accepted. So this is the correct formula for calculation of connecting rod angle and the slider location verification. So here the value of d has been actually just verified, so that value of the connecting rod angle will be accepted, and that formula will be actually used, which will be giving the correct value of the slider. So this formula has given the correct value of the slider, so that means theta 3 2 is the correct formula for the solution. So in the similar manner, if we count the values for theta subscript 2, so theta 3 1 formula will be giving theta 3 value this, which is incorrect, and the resulting value of slider location is also incorrect. And if we use the other formula for theta 3 2, which is giving this result, which is equal to 214.7454, and as we can observe here the result that graphically calculated, which is equal to 215, so the result is very nearly equal. So this is correct, and the corresponding D value is 600.8016 millimeter, which is also 100% correct. So here I have typed here the detailed procedure for theta 21. If we apply this formula theta 31, so theta 3 value is this. So corresponding slider location when inputting these values, these are actually giving. So I have detailed mentioned here the solution, so you can pause the video and solve it yourself in this way. And I have also tabulated the result. So in a similar manner for theta 2 subscript 2, so I have again calculated all the four values and the corresponding slider location, as we can observe here. And now I have correct values of theta 21 and theta 22 angles, and the connecting rod angles have been mentioned here. Theta 21 graphical result is 60 degree, as we can observe. Analytical result is 59.228, and theta 2 for theta 2 graphical result is actually 19 degrees clockwise or 341 degree counterclockwise, and a similar analytical result are shown here. And for theta and theta 31 is equal to 186 degree counterclockwise or analytically 1.85.527 in the similar manner. So the results are listed here. So in this way, this is the solution for question number third, part number 2. So now the solution for question number 3, part 3. So the statement here is that write the vector velocity equation, vector loop equation for the crank slider linkage. As we can read the statement from here, that write the vector velocity equation for the crank slider linkage if theta 2 is 60 radian per second, and draw a neat labeled velocity triangle for only the circuit on the right of the crank. So that was only the requirement, that student will only be drawing the velocity triangle for the right hand circuit, but I have drawn the velocity triangle for both circuit and measure and list the magnitudes and direction of the relative velocities and absolute velocities of the slider, and the angular velocities means clockwise or counterclockwise means you will also be mentioning the orientation of the connecting rod. So coming toward the solution, as we can observe, first we will first of all be this equation was actually for the we can observe here in the statement that actually the solution was for crank dash slider. So correct mentioned is here that for the crank dash slider mechanism, omega 2 assumed 6 radian per second. So here the magnitude of the input velocity, which is actually crank, so that came out to be 200 millimeter. So scale was chosen 300 millimeter per second, so which is equal to 1 centimeter. So VA becomes 4 centimeter. So the velocity equation is actually VB is equal to VA, because this is the input, and VBA is actually the connecting rod relative velocity. So here is actually shown the vectors are shown on the actual schematic diagram for the crank dash slider. This is the right hand slider location, and this is the left hand slider location, and this is the perpendicular velocity vector at correct angle has been drawn, and this line is actually perpendicular to the connecting rod AB, which is actually giving the orientation of the relative velocity VB relative to A. VBA means relative velocity of point B with respect to point A, this crank point. And in this way the velocity diagram for the slider has been drawn here, as we can observe, and I have explained the procedure for drawing this diagram many times, that we will be uh, mentioning or locating the value VA at the correct angle, which is equal to 45 degree, because the crank was at 45 degree, so this angle VA with the horizontal is 45 degree. And in a similar manner, after that we will be drawing this VBA, because its orientation is known, so we will simply be moving this line at the same angle at that can be measured from this diagram, so that will be moved, and the slider actually is restricted to move horizontally. So this is the slider line, so here will be the intersection, and after that we will be making inputting these arrow vectors. So as we can observe here, that VBA, from this velocity triangle we can also observe that the angular velocity or the rotation of the connecting rod, this right connecting rod, the direction of its rotation will be clockwise, because this point A, its tail will be located at point B and its arrow will be located in here. So as we can observe, this will be trying to rotate this connecting rod AB in the clockwise orientation. That means angular velocity for this right hand side slider location connecting rod is clockwise, and slider location is actually towards negative x-axis. So here I have verified the graphical result have been listed here. VBA according to scale is 2.9. here VBA, this vector according to scale is 2.9 approximately. Remember, 1 or 2 graduation mark can be possible, so that is equal to nearly equal to 870 millimeter graphically, and omega A is actually obtained by dividing VB relative to A divided by the length AB, which is equal to 500 millimeter. So this comes out to be 1.47 radian per second clockwise. In a similar manner, V subscript B, which is actually V subscript B, which is actually the velocity of the slider located at the right hand side. So this VB is equal to 2.5 according to scale. Scale is 300 millimeter, so this will be multiplied by, this will be equal to 750 millimeter per second. And analytical result, these are the analytical formulas copied from the book, and the equations are actually showing the same number as in the textbook. So this is actually a snapshot from the textbook. So in chapter 6, equation number 22.A and 22.B. So angular velocity, so if input the data, we can observe here, you can verify the result yourself. So the angle, this angle 189.0419 is actually taken from the analytical results, because while verifying the analytical formulas we will be inputting the analytical angle results, not the graphical results. So remember that while using these formulas, always input the analytical angles and analytical velocities, etc. So this result is equal to minus 1.718. so minus sign here actually denotes that the rotation of the connecting rod, or link number 3rd, is clockwise as mentioned here. So graphically it also shows that the connecting rod on the right hand side is actually rotating clockwise orientation, and the analytical results are also showing the same. and the slider location, as we can observe here, that is also showing that the slider location is this -713.5, and our result here is shown that VB is equal to 750 millimeter. So remember that the one or two graduation make a lot of difference, so our results are sufficiently accurate. So if the procedure is correct, so the results are almost matching, so it is all okay. So as we can observe that d dot is the velocity of the slider for the right hand slider location. In a similar manner, if we move toward the next page, the velocity diagram for the left hand slider, this has been optionally drawn. So in a similar manner, these extended lines have been used just to measure the angles, so that these lines actually cross or meet the graduation marks on the protractors. If the vectors have some other lengths, so we can extend these lines so that they actually match or meet the angular calibration markings on the protractor. So these lines have been extended, and in this way these are actually the angles have been measured with the help of protractor, so you can measure them physically. So these angles are shown here, and this is the graphical results here. The angular velocity is same, but here the angular velocity is positive, mean clockwise. So the slider for the connecting rod for the when the connecting rod, when the slider will be located in the second quadrant or in the left hand side, we can observe that the velocity vector will be here, so that will actually be rotating the connecting rod in the counterclockwise or positive orientation. So due to this reason, we can observe here that here the value magnitude is same of rotation, magnitude of rotation is same, but the direction of rotation for this sorry here for the for right slider, this has been copied, here must be left side slider location. So for the left slider location, the direction of rotation will be counterclockwise, means positive, and VBA value is 1020 millimeters, as we can observe here that according to scale this is equal to 3.4 multiplied by 3, so this comes out to be 1020. And here the analytical results are shown here, that here we can observe analytically the value is 1.718, which is actually positive, so that means counterclockwise. And here the D value is also shown here, which is equal to somewhat result is minus 983.52. Minus sign actually shows that the slider is located in the second quadrant, so you can verify the results yourself. As we can observe here, the direction is in the negative direction. So in this way the whole solution have been shown here. If you have still any confusion, you can personally meet and ask. Thank you and assalamu alaikum. God bless you.